Welcome to section 5. Until now, we have been writing all our code inside a single block. But as programs grow, this becomes messy and hard to maintain. This is where functions come in. A function is a block of code that performs a specific task. You write it once and use it whenever you need. Why are functions important? They make code reusable. They make code clean and organized. They help avoid repetition. They make debugging easier. Think of functions as small machines inside your programs. You give input, it processes it and gives output. Let's learn how to create them. In Python, we define a function using the def keyword. Example, def greet print hello, welcome to Python. To call the function, simply write greet followed by parentheses. Key points. The function runs only when you call it. Functions can contain any number of lines inside them. They help keep your program organized. Let's create another example. Def welcome. Print. My name is Vivek and this is the Programmer's Hub Python course. Calling the function. Welcome. Simple and powerful. Functions become more useful when they accept input and return output. Parameters are used for providing input to functions. For example, def greet name, print format string hello name. Calling greet Aisha. Here Aisha goes into the parameter name. Return values are used for getting output from functions. Sometimes we want a function to give something back. For example, def add a comma b, return a plus b. Calling result equal to add 10 comma 5, print result. The return keyword gives the result back to the caller. Key points: use parameters when you need input, use return when you need output. Functions help break complex tasks into small parts. Now let's talk about default arguments and keyword arguments. Python allows two very convenient features: default arguments and keyword arguments. These features make functions flexible and user-friendly. Default arguments. Def greet name equal to guest. Print format string hello name. If you call the function greet without passing any value, greet, output will be hello guest. This provides flexibility, improves readability and maintains backward compatibility and prevents errors when arguments are omitted. Keyword arguments. For example, def intro name comma age, print name comma age. We can call the function with parameters used as keyword value pairs. Intro age equal to 25, name equal to Rahul. This is convenient in the sense that order doesn't matter when using keyword argument. Python offers a shortcut for small single-line functions called Lambda Functions or anonymous functions. Example, square equal to lambda x into x. Print square 5. Another example, add equal to lambda a comma b, a plus b. Print add 3 comma 4. Lambdas are great when you need small temporary functions. You don't want to define a full def block. Lambdas are widely used in data science and functional programming. In this lesson, we will take up three powerful functions used in Python for processing data: map, filter and reduce. These functions help process lists efficiently. First, map. Map function is used when we need to apply a function to every element within a list. Let's take an example. Numbers equal to 1, 2, 3, 4. Squares equal to list map lambda x into x, numbers. Print squares. This particular function will print square of every number within the defined list. Second, filter. Filter function is used when we need to keep only items that satisfy a condition. Let's take an example. Numbers equal to 1, 2, 3, 4. Evens equal to list filter lambda x modulo 2 equal to 0, numbers, print evens. This function will filter out even numbers from the list and print them out. Third, reduce. Reduce function is used to reduce a list to a single calculated value. Let's take an example. From func tools, import reduce. Numbers equal to 1, 2, 3, 4. Total equal to reduce lambda a, b, a plus b, numbers, print total. This function will sum up all the elements in the list and give the sum. In this lesson, we will take up the concept of modules and packages in Python. A module is simply a Python file that contains functions, variables, or classes. The Python standard library contains well over 200 built-in modules, though the exact number can vary significantly depending on the specific Python version and the underlying operating system or configuration. These modules cover a wide range of functionality, including mathematics, performing complex mathematical operations, for example, math, CMath, data handling, working with dates, times, and container data types, for example, datetime and collections, system functions, accessing system-specific parameters and functions, for example, sys and os, file management, reading from and writing to files and managing compression, for example, CSV, JSON, PZ2, networking, implementing network protocols and handling data encoding, for example, base64, async, IO. Let us discuss some of the built-in modules in detail. Math, random, datetime, and OS. First of all, the math module. This module provides access to common mathematical functions and constants, including those defined by the C standard. Complete documentation for the function can be found at docs.python.org/3/library/math.html. Some of the categories of functions which are available in the module are number theoretic functions, floating point arithmetic, floating point manipulation functions, power, exponential and logarithmic functions, summation and product functions, angular conversion, and constants defined in the math module are pi, e, tau, inf, and nan. For using a function from within a module, we need to import it and then call the function by prefixing with module name. Example, import math. Use the math.square root function to calculate the square root. Number equal to 16. Square root result equal to math.square root number. Print format string. The square root of number is square root result. Use the math.ceil and math.floor functions for rounding. Decimal number equal to 7.4. Ceiling result equal to math.ceil decimal number. Floor result equal to math.floor decimal number. Print format string, the ceiling of decimal number is ceiling result. Print format string, the floor of decimal number is floor result. Access the math.py constant. Pi value equal to math.py. Print format string, the value of pi is pi value. Calculate the sine of 90 degrees. We must convert degrees to radians first. Angle degrees equal to 90. Angle radians equal to math.radians angle degrees. Sine result equal to math.sine angle radians. Print format string, the sine of angle degrees is sine result. We can also import the specific function from the module. Then there is no need to prefix with module name. Example, from math import square root. Number equal to 16. Square root result equal to square root of number. Print format string. The square root of number is square root result. Next, random module. The Python random module is a built-in library used for generating pseudo-random numbers and performing random operations for simulations, games, and data analysis. Complete documentation for the function can be found at the shared link. Example, import random. Simulates rolling a 6-sided die and returns the result. Def roll dice. Dice roll equal to random dot random integer 1, 6. Return dice roll. Run the simulation and print the result. Result equal to roll dice. Print format string. You roll the result. So here we see that in this particular function, roll dice, we are calling the random integer function from within the module to generate a number from within 1 to 6. Every call of the function will generate randomly any of these 6 numbers. So we can simulate a dice roll by calling this function. As we said, result equal to roll dice, and then we can print that particular result. Next, datetime module. The Python datetime module provides classes for working with dates, times, and time intervals in an efficient and standardized way. It is a built-in standard library module and is essential for applications requiring scheduling, logging, or time series analysis. Complete documentation for the function can be found at the shared link. Example, import datetime. First, get the current date and time, a datetime object. Now equal to datetime.now. Print format string current date and time now. Print format string current year now.year. Print current month now.month. Print format string current day now.day. Second example, create a specific date, a date object. My birthday equal to datetime.date 1990, 06, 15. Print format string my birthday. Example third, perform date arithmetic using time delta. Calculate a date 30 days from now. 30 days equal to datetime.time delta, days equal to 30. Future date equal to now plus 30 days. Print format string date 30 days from now, future date. Example 4. Calculate the difference between two dates. Days since birthday equal to now date minus my birthday. Print format string days since my birthday, days since birthday dot days. Example 5. Format a datetime object into a specific string format. Format as month, day, year, weekday. For example, October 25, 1990, Thursday. Formatted date equal to my birthday dot string format time %b, %d, %y, %a. Print formatted string, formatted birthday, formatted date. As we see, the string format time function uses format specifiers as parameters. The complete list of these format specifiers is detailed for your reference. It has date directives, time directives, and combined date and time and locale directives. Next, OS module. The OS module in Python is a built-in standard library module that provides a portable way to interact with the underlying operating system. It allows Python programs to perform a wide range of system-level tasks such as file and directory management, accessing environment variables, and process management across different operating systems like Windows, Mac OS, and Linux. Complete documentation for the function can be found at the shared link. Example, import OS. First example, get the current working directory. Current working directory equal to os.getCwd. Print format string, current working directory, current directory. Second example, create a new directory. os.makedir new directory, print format string, directory, new directory created in os.getCwd. Third example, list files and directories in a path. Items equal to os.listdir within brackets dot. The dot refers to the current directory. Print items in the current directory, comma, items. Fourth example, check if a path exists. os.path.exists new directory, print the directory exists, else print the directory does not exist. Fifth example, remove an empty directory. os.rmdir new directory, print directory, new directory removed. We have thoroughly understood the concept of built-in modules in Python. We can also create our own modules to meet our specific requirements and extend Python's functionality. Let us see how we do that by using an example. Step 1. Create a new file area.py and create two functions. First, rectangle, which calculates area of a rectangle given its length and breadth. Second, circle, which calculates area of a circle given its radius. Area.py. Import math, def rectangle L, B, return L into B. Def circle R, return math.py, def circle R, return math.py into R into R. Step 2. Create a file named main.py and import the area module. Main.py, import area, print format string area of rectangle equal to area.rectangle 10,8, print format string area of circle equal to area.circle 5. This is exactly how large Python projects are built, by splitting code into multiple modules. Understanding modules is the key to writing large structured programs. After understanding the concept of modules, let's move to the concept of packages. What is a Python package? A Python package is a way to organize related modules into a folder. In simple words, module equal to single Python file, package equal to a folder containing multiple modules. Packages help keep large projects clean, structured, and easy to maintain. Real-world analogy. Think of function as a tool, module as a toolbox, and package as a cupboard full of toolboxes. Packages help us to organize large programs, avoid naming conflicts, reuse code efficiently, and maintain professional project structure. A simple Python package looks like a folder with the module files inside. For example, let us take the example of a utilities package with the maths_utils.py and string_utils.py modules within, and the folder should also contain a init.py file which is typed as _init_.py. Here utilities is the package name, init.py tells Python this folder is a package, and math_utils.py is a module, string_utils.py is another module. Even an empty init.py file makes a folder a package. Let's try to create a package. Step 1 is create a folder named utilities. Inside the folder, create files init.py, math_utils.py, string_utils.py. Step 3, add code to
the files. For example, we add some code to math_utils.py. Def add a comma b, return a plus b. Def multiply a comma b, return a into b. Similarly, add some desired code to string_utils.py. To use a package, we first need to import it. So let's see how the package is imported. Import utilities.mathutils, print utilities.math_utils.add 5,3. To import a specific function, we use the from directive. From utilities.math_utils, import add. Print add 10, 20. Importing with an alias. From utilities, import math_utils as mu. Print mu.multiply 4, 5. Third-party packages are packages created by others and installed using pip. Examples are numpy, which is used for numerical computing, pandas used for data analysis, requests used for HTTP requests. Let's see the example of installing a package. Pip install requests and then using it, import requests, response equal to request.get, https example.com, print response.status_code. Real world Python projects always use packages.
Try these exercises. First, write a function to calculate the area of a rectangle. Second, write a function that checks whether a number is prime. Third, create a lambda function that multiplies two numbers. Fourth, use map to convert a list of Celsius values into Fahrenheit. Fifth, create your own module called calculator.py with add, subtract, multiply, divide functions. These exercises help you apply everything you learned. Let's build a small but useful project, a unit converter. Features: convert kilometers to miles, convert kilograms to pounds, convert Celsius to Fahrenheit. First, let's create the module file with the three converter functions. Converter.py, def kilometer to miles kilometer, return kilometer into 0.621371. Def kg to pounds kg, return kg into 2.20462. Def c to f, c, return c into 9/5 plus 32. So here we see that we have used all the mathematical conversion functions for kilometer to miles, for kg to pounds, and for Celsius to Fahrenheit. Now let us create the main project file which will call and use these module functions. Project.py. From converter, import kilometer to miles, kg to pounds, c to f. While true, print 1 kilometer to miles, print 2 kg to pounds, print 3 Celsius to Fahrenheit, print 4 exit. Choice equal to int input, enter choice. So here we see that we have given the menu within the infinite while true loop, and depending upon whether the user enters a number from 1 to 3 or whether he enters a 4 for exit, we will keep on running this program. If choice equal to 1 means the person wants to convert a kilometer value to miles, km equal to float input enter distance in km, print format string distance in miles equal to km to miles km. So here we are calling the km to miles function from the module. If choice equal to 2, kg equal to float input, enter weight in kg, print weight in pounds equal to kg to pounds kg. If choice equal to 3, c equal to float input, enter temperature in Celsius, print format string temperature in Fahrenheit, c to f, c. If choice equal to 4, print goodbye, break. So in case the user enters the choice of 4 means he wants to exit, then we'll break out of the infinite while true loop. Else means In case a person adds entry which is neither of the four numbers, then we need to say that the choice has been invalid. We print an invalid choice message and the loop will again iterate. This project reinforces functions, conditionals, loops and modular code. Excellent job completing section 5.